Welcome to a new session of JTA class with myself, Rab Bruce-Lockhart. That is a scary thought. We'll see how this goes. Today we're going to talk about context engineering, which is basically the science or art of configuring the right amount of context to deliver to a large language model. And if we look at a really quick example or diagram, in this case, we have a preset context window, and this is all the possible information, instruction, tool calls, i.e. context, that we can pass on to the LLM. So we have reference documents, we have tools, we have a memory file, we can encode domain knowledge from different teams and departments, create comprehensive instructions or rules for the large language model and agent to follow, and then carry through message history. And in this case, we'll pull through in the actual context window a particular preset system prompt. We'll have a couple of tool calls and guidance around that, maybe a reference document, memory file, perhaps some user messaging in terms of their own custom prompt, and then it will have access to the message history. And that's going to get delivered to the large language model. So that's, in this case, let's say the most effective amount of context that we're going to carry forward to the LLM so that it can ultimately maximize its ability to execute in an accurate way. And that's just going to very simply result in an assistant message or a tool call, which will have a tool result. And a tool might be a calculator. It could be a SQL query generator. It could be basically things that the large language model isn't good at naturally to augment its capabilities and support these agents with surrounding staff, if you will, so that they have places to go for more effective execution. And that then ultimately all gets compacted and brought back into the message history, which can be carried forward, but we'll get to that in a moment. So why is context engineering so important? Well, it's critical mainly for accuracy, especially in an enterprise context, because of this reality and idea of context rot. And what is context rot? Well, context rot is basically where you have the large language model's performance or accuracy on our y-axis and token consumption on our x-axis. And over time, the accuracy is going to fall off a cliff as we have more and more token consumption. And that downward trajectory is ultimately what we call context rot. Now, why does context rot happen? Well, it happens because of the very way that large language models are architected. And they're based on something called the transformer architecture, which was invented in the very groundbreaking paper, Attention is All You Need, which was put out by Google and my alma mater, U of T, but I certainly wasn't close to it. And the key word in this is attention. Attention is ultimately what gives large language models the ability to focus on the right tokens or focus on the right information. And it means that any token can attend to every other token in its context window. So for instance, just to break that down in a simple example, if we have 5 tokens, and a token, by the way, is basically, think about it like a unit of LLM cognition. So it could be like a word, or a word could be represented by multiple tokens. But yeah, a unit of LLM cognition is a good way to think about it. But in this case, we have 5 tokens, and attention means that each token must be able to attend to every other token in this context. So token 1 must be able to attend to token 2, token 3, token 4, and token 5. And conversely, token 2 would need to be able to attend to token 1, token 3, token 4, and token 5. So in this case, we have n, and let's say n equals 5, the number of tokens. But because of attention, it's actually n squared, which equals 25. That's not a big deal when we're dealing with 5 tokens, but in a practical example, especially in an enterprise, if you're doing due diligence, legal, research, large finance tasks, especially with a lot of reference documents and tool calls, this number can grow exponentially, because if n equals 5,000 instead of 5, then n squared equals 25 million. And 5,000 isn't even that much. That could be a legal document, for instance. So that means attention needs to be treated as a finite resource. We need to design the architecture and really think about context engineering from the day zero design to maximize LLM utilization and maximize the amount of attention that we have. And there's a couple interesting ways that that can be executed in terms of the actual design of the architecture itself. One of them being compaction. And compaction is a super simple idea where you're basically taking the Cole's notes, if you will, as a context window approaches its limit in terms of token consumption, and you're summarizing it, which LLMs are very good at, and passing that onto a fresh window. So let's say you have context window 1, CW1, and you start to end the limit in terms of token consumption. You have a mechanism through the LLM, which are really good at summarization naturally, to summarize the most important parts and take that to context window 2. It's kind of like the highlights recap at a season finale, or again, sort of the Cole's notes. And that can be really good for more long horizon tasks. Think about writing a long contract, for instance, with a very preset table of contents. Every compaction could be another section in that contract. Another way to go about it is running out of room here, sub-agent architecture. Basically, where we have our primary agent that would be focused on one particular task, like narrative. So let's say we have this LLM, and let's use the legal example again, just because of consistency. And that LLM, let's say, is really focused on developing the narrative and producing the actual legal document, but it has access to sub agents that can focus on other things, like in one case, maybe research for legal precedent, and looking at a vast amount of case studies or references or case files in a vector database. Another one may be focused on counter arguments, for instance, but they're ultimately going to take their output, condense it down, and deliver it back to the primary LLM to craft the narrative. And again, that's really thinking about how do we maximize the yield we can get and maximize the amount of attention for the task at hand. Thank you.